Yeah, so in the second video, I want to briefly talk about NumPy array construction and indexing. So array construction routines are some built-in routines or functions that I find useful for constructing arrays. And that is sometimes useful if you want a placeholder array that you want to fill out with certain values later, for example. So let's show you what I mean. So using the ones function, we will create an array consisting of only the numbers 1. Could look like this. And note that this is defining the shape. And the shape is here 3 by 3. I can also make it 3 by 4. And then it will be a 3 by 4 matrix consisting of ones. There are many other types of arguments you can provide. For example, a D type, you can set it to integer. So integer 64 or integer by default is the same if you have a 64-bit machine. So it will be an integer array of ones and so forth. And the same is true for the zeros. So always remember, if you want to find out more information about these functions, you can type NumPy once in the help function. So you can call help on this one. It will give you some information here. Personally, if I'm already in a Jupyter notebook or IPython interactive shell, I usually use the question mark, which is once, which is usually faster, and it also gives you the nice color here. Usually it's easier to read this way, I think. Yeah, there's more information here. So the shape, for example, the D type, by default it will be the float 64. And there's also something called order. There's something called a column or row order, and it has something to do with the fact how things are laid out in memory. So C stands for C code. So in C code, it's using the row major style in memory. And if you choose F, I will do a Fortran style layout, and you don't really have to think or worry about it in practice. It won't change the results or anything if you do a computation. It's just how the arrays are stored in memory, and this would make it more efficient if you couple your NumPy code with C code or Fortran code in certain applications. But in this class, you won't have to worry about things like that. It's just an additional tool in a software engineer's toolbox to make NumPy arrays fast with both C and Fortran code. Anyway, so it was maybe too much detail. All right. Yeah, maybe why these placeholders are useful. I mean, even though, let's say you have, you want an array that consists of all the values, should be all 99. So each value should be 99. How you would create it, you can still use this zeros function, for example. You can do zeros plus 99, for example. It will create your array. So these are pretty efficient, I would say, ways of creating arrays quickly. I usually use either ones or zeros. It doesn't really matter. Sometimes it depends on what I'm trying to do. I use either or, but we will see examples of that later. Just wanted to mention that these exist. There's also one called empty, which makes a completely empty array. So we will talk more about this later in this class when it's useful, but empty is usually a little bit faster, because it doesn't fill the array. It just creates an empty array. It doesn't fill it with memory values in the memory. But usually in our application, we don't have to worry about these little details. So by the way, it will just put some arbitrary values in here, some arbitrary values from memory. So here it's just coincidentally 99. But could be some arbitrary values. So if you use empty, don't pay attention to the actual values, just treat it as an empty array. It's just using some method, the fastest method possible to create an empty array, basically, without worrying what goes inside. But yeah, actually that's maybe too much information for this class. So there's also the I function, which is, I think, like a nice pun on the identity matrix. So this will create an identity matrix. A 3 by 3 matrix. You can also create a diagonal matrix consisting of the values 3. A 3 by 3 matrix consisting of the values 3. Let's maybe use a different number here because this would be, okay, sorry. These are the values along the diagonal. See, I already forgot what these mean. So it would be 1, 2, 3. So we can create diagonal matrices like that. And this is usually something we rarely have to do. What's more useful though is talking about the arange function. So the arange function will create NumPy array starting at the first value and stopping at the second value, and this will be a half open interval, so this will be the start value, and it will be up to the 10 but not including the 10. So let's create this object. So you can see it's doing 4, 5, 6, 7, 8, 9. You can also do this with integers. And you can also just omit the stopping position, so it will here create the values 0. So if you only use one value, it will be actually the stopping position. So if you only use one value, it will be 0, 1, 2, 3, 4. So, and this is similar to using a Python range object, right? So actually nowadays it's a generator, so we have to, if we want to show it how it looks like, call list on it. So, but this will be a Python list, and this will be a NumPy array. So it's kind of equivalent in that way. You can also include a step here. So this means basically skipping every second value. In this case, it will, so for instance, here it will then skip all the even values. Yeah. So 1, 3, 5, 7, 9. So it will start at 1, and then all the second value will be, every second value will be included then. Okay. And yeah, the arange function is essentially what you know from Python as the range function, but range can't do floats, right? Oops. So we can't do this in range. However, we could, if we wanted to, do it with integers, so this would be the integer equivalent. Yeah, one very useful function is the linspace function. So arange creates numbers in a certain interval, and you have to specify what the interval is. By default, it's 1, so it's incrementing it by 1. However, maybe it wasn't quite clear here. So we can actually increment it by very small values. We can increment it by very small intervals, like 0.1 here. So in this way, using arange, we specify the interval range. A related function is the linspace function, and this will create an interval with a certain number of values. So here we specify the starting point and the ending point, and then we say how many values we want in this interval. So again, here we specify the interval width, and here we specify the total, so the bin width, and here we specify the total number of values in that interval. So here should be 5 values. So you can see it starts at 0, ends at 1, and there will be 5 values in total. So 0, 1, 2, 1, 2, 3, 4, 5. And I can then also, let's say, create 10 values and so forth. And it works with arbitrary intervals. So I can use my interval, let's say up 5 to 15 or something like that. It will create values between 10 values between 5 and 15. And yeah, these values are evenly spaced. So I could, for example, go here, enter a 6, and then we will have 6 to 15, which are exactly 10 numbers, right? So in this case, they will also, you can maybe more easily see they will be evenly spaced. Okay, so yeah, what's useful to remember is the arange function for creating intervals with a specified bin width, and the linspace function for creating a certain number of values in a certain interval. And then, yeah, also the basic array creation functions like zeros and ones. And I'm not asking these things on the exam, by the way. I don't ask you to create an array in the exam. At least I don't plan to. But it's useful to know that for the homework and your project and so forth. So let's talk about array indexing. And note, I will talk about fancy indexing in a later video. So this is just the indexing basics. So the very basic way of indexing a NumPy array. Later, I will talk about a concept called fancy indexing. So for a one-dimensional array, the indexing works similar to a Python list. So if I have a Python list, let's call this LST, and we put the values 1, 2, 3 in here. If I want to retrieve the first value, I use the square brackets, right? So it's the 1, and this is the value 2, and this is the value 3. In the same way, we can do this in NumPy array. So if you have a one-dimensional NumPy array, we use the square brackets to retrieve these numbers. What's also useful is the slicing. We can also do that in a Python list. So we can execute it like this, and it slices the list. Same way we can slice a NumPy array. Note that it's the same for Python lists and NumPy arrays. We don't have to write the first index if we start at 0. If I do something like this, I would include the 1 because I want to start at the second position. However, if I want to start at the beginning, this one and this one, this is exactly the same. Next, if I have a two-dimensional array, that's what's different from Python lists. So we have a two-dimensional array instead of a one-dimensional. Now we can use this comma notation. So the first position refers to the index over the first dimension, and the second one refers to the index over the second dimension. It's maybe easier to see in this figure. So with this first value, we are indexing over the first dimension, which is the axis 0. So we access either the first row or second row. And with the second number, we index over the second dimension. So we go by first column, second column, third column. So in that way, this one would give us the first value because it's the first row in the first column. And if I do this one, for example, so let me just execute it to show you that this is actually correct. So it gives me the 1 here. So this one would give me the number 2 because it's still the first row, but now it's the second column, and so forth. We can get the lower right with -1, -1, so this should return the 6. And this is because -1 means the last element. So here, if I do a -1, this would return the number 3 because it's the last element. So it's the same as typing 2. However, if why is it useful to use the minus? If we have a very big array, it can be inconvenient to count. So we would have 1, 2, 3, 4, 5, 6, 7. So if we want to have the last value, we don't have to really memorize what the length of the array is. We can just type -1. It gives us the last value. And then again, you can do also the same thing. -2 would be the second last. In this case, this is the last one, and this is the second last one. So it should return a 2 here, and so forth. Here's just another example that's returning the 4 here because it's the first row, and actually this should return a 5. I'm not sure why I put the image around here. Sorry, I was confused. So this should return the 2 because it's the first row in the second column. I was not 1 would return the 5. I don't know what I did here. Anyways. We can also return an entire row. So if we omit the second, so if we do this or this, it will give us the entire first row. I think this should also work. And we can also type this. All 3 ways give us the same results. So this one, the column basically means all. So we want all values. So if I do something like this, it will give us all the values in the array. And this one basically 2 because we are omitting the second one. So if we omit something, then it automatically means this one here. So for example, if I want the first column, I can do the 0 here. So it's 1, 4, 1, 4. Second column, it's 2, 5 by going over the second column and so forth. If I only want the first row, I can do it like this. So it's 1, 2, 3 because we omitted the second one and so forth. So yeah, here just shortcut, some annotation, entire first column. So that's what I did before. And we can also slice in the second dimension, like we sliced in the first dimension. So I can, for example, say the first 2 rows and the first column, second column. So this would give me the 2, 5. Because we go over the first 2 rows, we only have 2 rows. Maybe this is not the best example because we only have 2 rows. And then we go for the first column. So let's maybe do the first row and the last 2 columns. So we can do 1, 2. So we can type 1, 3, because the last value is not included. It's similar to the A range. When we have NumPy A range 3, it will only give us 0, 1, and 2. So in this way, the 3 is not included, so it will end up at 2. So this gives us, for the first, the row in the second position, because we started indexing 0. So we'll go here, and then the last 2 columns are these 2 here. And that's why it's 5, 6. Yeah, and that's returning the first element in the upper left corner. I'm not sure why I put it here again. Yeah. All right, so that was the basic indexing. So I recommend you to toy around with this. It's not super complicated once you get a hang of it. You just think of this first dimension here as the rows if you have a 2-dimensional array, and the second dimension as the columns, and then you can specify which rows and columns you want, and that's all you need to know about indexing for now. But later on I will show you some tricks called fancy indexing. Alright, in the next video I'm going to show you some NumPy array math and universal functions.